you know, with high or height level windows without reinforcement. If you have curtain walls, all of these things, you still need aluminum. The durability of aluminum is still nothing like aluminum. The recyclability and the reuse of the material is very green, so the carbon footprint is dramatically reduced. And you have a flexibility that you can do a lot of things with aluminum and aluminum extrusion. To briefly explain for those who don't know what is thermal break, or they are new to this field, really what thermal break is doing is separating your window outside from inside in a way that the metal don't touch each other, don't meet each other. And the polyamide strips in the middle, which you see in dark in black, they are really separating the window from outside and inside. And the reason why we use polyamide is because of the conductivity of the material itself. While aluminum has a conductivity of 160 watts, the one of the polyamide is 0.3 only. That means you have 500 times less conduction of energy from outside to inside or from inside to outside. When I say that, what I mean is that if you have hot weather outside, 40, 45, 50 degrees, and you have air conditioning inside at 20, 22, 25 degrees, you can isolate your windows so that you don't use excessive energy for the air conditioning. And similarly, in colder countries like we have in Europe, for example, outside we have cold weather, maybe 5 or 0 or -5 degrees, and inside we have heating systems at, again, 20, 22, 25 comfort levels, and there again, you can isolate that with using thermal break. But of course here, even though in Delhi and the north you have colder climates, more or less all over India, just like we have in the Middle East, it's more for the heat. And you can see only for air conditioning, you can save, depending on the quality of your window, between 40 to 80% energy. The energy flows through a window in 3 different ways. Through the material, what is we say is conduction, is about 50% of this transfer. 15% is through radiation of the metal, and you have convection, which is around 35%. So what we are trying to do in a window is to treat all of these 3 aspects in order to reduce the flow of the energy. I said before, 500 times better or less conduction through polyamide. The structural performance of polyamide is as such that it's very precise, and there are glass fibers inside which are giving the structural strength to the aluminum, so you do not lose any structural strength for the aluminum profiles if you are using the thermal break system. And this is a very important point, the rate of expansion and contraction. While in PVC, for example, you need to place steel inserts for reinforcement which move at completely different expansion and contraction rates, the polyamide and aluminum have similar rates of expansion and contraction. That means you will never have any dislocation of the profiles. They're chemically resistant to all window cleaners. Another important point is the melting temperature. You can have a minimum of 250 degrees resistance. That means you can powder coat your profiles either before, separately, if you are doing 2 color profiles, outside 1 color, inside 1 color, and then assembling them together. Or you can actually assemble first the profiles with the polyamide and coat the entire thing if you do not wish to see the black strips. The same for anodization. And this is not a new field. I mean, it's over 40